Bismillah Rahman Rahim. Hello and welcome to the 11th video of the Rust series. Today we will explore and learn what are closures, what are iterators, and we will also explore that how we can iterate over different vectors and arrays, as well as we will review the performance of the closures and iterators. So I'll also share the different methods and the uh, documentation from the Rust book. I have a Rust programming language book with me. So I'll also share different methods and different detailed stuff from the book as well. So before getting into today's topic, think we should review or we should get a recap of our last video. So what we did in our last video, so we have covered we have built the CLI application in our last video where we got the input from the user through CLI, the arguments from the CLI as well, and then we have read the file from the user's file system, and then we got we have searched the specific query from the file whether the specific word exists in the file or not. So let's just get a review of the code. We have organized our code and we have split it into the lib macro as well as and the main function. So you can see that we have the search query where we have used lifetimes, and there are multiple concepts. This is the lines. We will get deep dive into the what lines is, what is enumerate. So this is the eprintln that we have reviewed, that we have, if we want to print the errors, we can use the eprintln macro. We have also explored what debug macro is, dbg exclamation mark, what's debug macro is, what's the difference between println and the debug macro. We have written some tests to test our different to test the functionalities that we have built. The search feature, we have tested how whether the program is reading the file perfectly fine or is there any errors or so. So that was pretty much it. I have already pushed the code to my repository, so you can explore the source code from there as well. Let me share the code with you. YouTube Rust Aggregate. So github.com/Hadi Heather 055/YouTube hyphen Rust. So let me show you. So I have already pushed everything on GitHub, so you can access from this URL. I have already added it in the description, so you can get it from there. So we have already pushed everything to do a Rust CLI lecture till lecture 9. So let's get into the today's topic. So Rust design has taken inspiration from many existing languages and techniques, and one significant influence is functional programming. We have yesterday, I guess, in our last video, we have discussed about what are closures, and then we have also compared it with the JavaScript syntax, that how we can use the closures in JavaScript. So we didn't get deep into the JavaScript syntax in our last video, but we will get deep dive into the Rust syntax as well as in the JavaScript syntax too. So function the closures are similar because Rust design is mostly similar to the functional programming. So I think we will also cover the Elixir, the functional programming too. Uh, Programming in a functional style often includes using functions as values by passing them in arguments. We can pass the functions as arguments, returning them from other functions. We can return a function from another function. Let me show you an example. So let's go into the VS Code, lecture 11, source main.rs. So what this line means, So we can, let's say, let's just get an example. We have a function, we can, let's say we have an argument function ABC, we have an argument, let's, okay, really, okay, so we can get the, let's say, function one as function. I'm not writing a perfect Rust code or any other language code. It's just kind of a pseudo code to where, let's say we can get the function as argument. We can also return function as, from a function. So what this is what this line means. So let me zoom in. Okay, so now programming in a functional style often includes using functions as values by passing them in arguments. So let's say if I have to consume this function, so what I have to do, let's say, let's just pass this function. It is not a good syntax. This is, it's just I want to explain it to you. So let's get it to the documentation. Yeah, where was returning from them from other functions, assigning them to variables for later execution, and so forth. So we can also assign the functions to different variables. So let's say let ABC is equal to a function. We can do that. In this chapter, we won't debate the issue of what functional programming is or isn't, but will instead discuss some features of Rust that are similar to features in many languages, often referred to as functional. More specifically, we will cover closures, iterators, how to use closures. These are pretty much it. So what I have prepared for you from beginning, that what are the topics that we will cover in today's lecture. So because let's move on to the 30.1. Yeah, closures, anonymous function that capture their environment. Rest closures are anonymous function you can save in a variable or pass as arguments to other functions. What does this means? That the closures are kind of an anonymous function, same as we have it in JavaScript. Yesterday, I have explained to you. Let me show you. Let's zoom in. Okay, yeah, perfect. Where is this? Go to the lib.rs. lib.rs, lib.rs, the CLI lib.rs, and here it is. Map, and this is a fat arrow function, or you can say the anonymous function. What anonymous function means? We haven't declared a name or defined a name for that specific function. This is a function, but we hasn't defined a name to it. So this cannot be uh, recognized by anyone. This is an internal callback function passed to the map function. Map itself is a function, and we have passed a callback function to the map. So don't become confused in that syntax. We will explore much more about closures later in a while. You can create the closure in one place and then call the closures elsewhere to evaluate it in a different context. Unlike functions, closures can capture values from the scope in which they are defined. We will demonstrate how these closures features allow for code reuse and behavior customization. And they are starting with uh, complex code. So what I don't want, I want it to simplify it to you. So um let's start with closures. What are closures? Let's start with closures. What are closures? So closures are the anonymous function. This yesterday we have also used a method, function, you can say, unwrap or else. Let me show you. Let it read file, and then you can say fs. Let's just import fs, fs and then read file, read read to string, and then we can pass any of the path. Let's say form.txt, and then here we can pass we can declare the expect method. Instead, we are now working with closures. We are now understanding what are closures. So we have unwrap or default. What does this means? Unwrap or else, or unwrap or default. Unwrap or default means if there is any value, then return it. If not, then print the default or return the default value. And or else means if there is okay result, then it's perfectly fine. Just return the okay. If there is not an error, then return something in that. So what we will do, we can we have multiple choices here. We can rather get an argument within, we can define, let me, we can, either way, we can define error here as a function argument, or else if we don't want to declare any argument, uh, we can make it empty. We can just pass the two bars, so to consider it as a function argument, same as we do with this functions. So let's say if I want to print something, let's just print and error. And okay, so we haven't returned anything. Process. Let's just do one thing. For now, just process dot exit and then return one. Okay, so let's save it, and then now one more thing. Closure is expected to take one argument, but it takes zero argument. There are there is another issue. What I have told you, that you have choice, that you can pass an argument if you want, or if you don't want to pass any argument, you cannot. You can remain this function, this argument can be empty. However, this choice will only be applicable to some of the functions. So right now, unwrap or else does not support this feature. It there is a requirement that you have to pass an argument. So we have passed an argument. Now it's perfectly fine. If we want to run the function, the program, I'll go run. Let's say मैंने program यहाँ पर चलाया, then we have an error because the form.txt file does not exist in our file system. Let's okay. So now let's move on to the documentation. Let's just skip it for now. Let me explain something. Let me explain iterators first to you. What are iterators, and then we will get back to the closures so that you can understand it much better in much better way, because there are a lot of methods right here. Let's say map, filter, reduce lines, map, filter, reduce, where we will pass the closures. So beforehand, we should cover what are iterators. So let's start with this one. This was the basic example of closures. Now let's move on to the closure. Okay, now closure, and then let's explain the iterators. Okay, so what's the simple way to iterate over a vector is just loop over it. Just run for loop, just run the loop, whatever you want. Let's say I have a vector of numbers, vec macro 1, 2, 3, 4. All right. And if I want to loop over or iterate over this vector, I can do directly like this. I in numbers, and then I can print numbers. Let's say I. Let's run cargo run command. Okay, so what we have 1, 2, 3, 4 printed on the in terminal. Okay, now there is another way to simplify it. What because in our last video when building the CLI we used iter function. What does this iter function means? Let's do one thing. Let numbers one numbers iter one. Let's just do one. And then numbers dot iter. What we are doing, we are iterating over, sorry, numbers. We are iterating over numbers. Now let's just see yeah, we are iterating over numbers. But there is another thing. If you, let me explain to you. So, okay, so iter function is called as a lazy function. What does this mean? This iter function will not run until we use it. How? What does this mean? It's it it is not right now. It is not in use because we have already declared that iterate over numbers, but we hasn't used it yet. So as soon as we use it, we consume it, it will iterate over numbers. Right now, it isn't using it. So let's say if I r- use it numbers iter one, and if I run the command cargo run, it will work same as was it was working previously. It's working perfectly fine, same as we did with direct for loop. However, if we want to use it with iter function, we can use it with iter function. So here is another method that we can use. Iter function, what it does, it takes the reference of the iterator. What does this mean? It takes the reference of the vector. It does not takes the ownership of the vector. Let's just do one thing. Let me revert this back and now now you can see that numbers cannot be accessible because the ownership of numbers is moved here. So whenever you iterate over a vector through for loop or any of the loop, so what it does, it takes the ownership of the array or vector. So let's say if there is a requirement that you don't want to give the ownership to loop or when iterating over the vector, so you can use dot iter function which only takes the reference of that specific vector and iterates over the vector. So this is pretty much it from this thing. We have another function if we want, let's say, if we want to take the ownership of the vector and iterate over this. So what we can do, we can use numbers iter to numbers dot iter we have into iter function. Now just save it. Now we have another issue. Here, now we have an error. Use of moved value numbers value used here after move. Because into iter function takes the ownership of the vector and then iterate over it. Mostly the concept is similar to iter. Both of these functions are same. However, there is a difference in this with respect to or in regards to the ownership or the referencing stuff. So iter will take the reference of the vector and into iter will take the ownership of the vector and then iterate over it. If we declare numbers.iter function right here, it will not affect or impact the performance of your program until we use this numbers iter1 and loop over it. Now it there will be some performance and processing will happen until we remove it. That's the major concept. अगर हमने iteration को use करना है, iter function को use करना है, so it's kind of the lazy loading. If we use it, it will be impacted or it will get the reference from the heap. If we don't use it, it will not impact the processing or the speed or performance of the program. So this is pretty much it from iter into iter, and there is another function iter mute. What does this mean? This is a function iter mutable. Let number iter 3. Let's just comment these items, and then let's say numbers dot iter and then mute. With the name, you can understand that it will mutate over the actual the origin this vector. So it will mutate over the numbers. So let me number iter 3. Now what does this mean? Now you can see cannot mutate immutable variable numbers because I'm not mutating the numbers vector is not mutable. So if I want to mutate over this vector, I have to pass the mute and then I can use the iter mute. So now how we can iterate over and how we can use it. So let's bring the other concepts or other functions into the scene. So okay, let's just wait to use it. We are not using it right now. We have covered the iter into iter and iter mute. You have, I think you got to know about the difference between all three of these iter functions, iter into iter and the iter muter or mutable. Now, iterator adapters. What does this mean, iterator adapters? So these are the iterator functions, and then the iterator adapters means that it will be kind of uh, it's not the iterate. It will not by itself iterate over the vector and return the uh, let's say return you the actual uh, vector. Instead, it's behind the scene map will use the iter function to process something. Now let's use it. So you will get to know about it better, or just use it right with this one. Let's just let me comment all these out. And let's just use the map function. What map function will do? Let's map. And then what I mean, now you can see that I'll use the closures in this map function too. So let me define the closure first. And for mapping, what does this mean, map? This means that I have to map over each index number. So let's say if I want to do some kind of, let's say x, and then what I want to do x plus 1. Let's just do this. Now, what you can see that x is a reference of I32, and then what I am doing, I'm adding or incrementing the current index, the value by 1. So let's just print the numbers iter. Let's just add the print statement here, and then let's just print. All right, okay. FMT display. here you can see map, iter, and then 1, 2, 3, 4. One more, one more thing. Now you can see it. What we have right now, we have numbers iter 1, and in numbers iter 1, we are getting 1, 2, 3, 4 as is. We are not. It's not it. What we expect is, or what we were expecting, that it should return with a increment by 1. And let me remove the iter function and just use the, okay, wait. Now you can see without iter function, it's saying the method map exists for struct vector integer, but its trait bounds were not satisfied. The following trait were not satisfied vector integer iterator, which is required by, so it doesn't satisfy vector integer iterator. So what this means, that we must have to iterate over the actual vector, and then for processing we have to return the x plus 1, and for that we have to do something here. Let me show you an example from documentation. Let's get into the documentation now, and then let's explain different functions to you. Let me just search for map right here. Right here you can see what they are doing. V1 iter dot map, and they are returning or adding, incrementing by 1. Map that must be used. Right here you can see. Now you have to add a method or function dot collect. What this dot collect means, I have added this dot collect into whiteboard to explain it to you. Map is already being explained, and now collect. What does this collect means? By name, you did understand that collect means it will collect over the iterate or the iterations. So how it will work, let me show you. By Let's go back to here. So first, what we have, 1, 2, 3, and 4. Okay, now it's iterating. The iter function will iterate over each of the index. So 1, 2, 3, and 4. And what map function will do, whenever, let's say, it's iterating over first index, then it will map out all these iterations and then add 1 into that. Let's say add 1, add 1, add 1, and add 1. So 1 will become 2, 2 becomes 3, 3 becomes 4, and 4 becomes 5. However, it is working fine. However, why it's not displaying by that it has added or incremented the values? So what we have to do, we have to collect the iterations. Now let's print out. Now you just wait. Okay, one more thing right here. Consider giving an explicit type. We haven't given the explicit type back. I clearly do. Now let's just print it out. Okay, now did you notice? Now we have a vector 2, 3, 4, 5 directly instead of this format. Map iter 1, 2, 3, 4. अब समझ आया होगा कि after collecting all the iterations, it will return a vector of integers or whatever type I have passed to the vector. If I hasn't be if I don't add or use the collect function, it will return the iterations, the iterator trait with the iterator trait. So I guess this is clear for you. If you have any queries, just let me know. I'll try to explain it to you. So Now let me take this mark. Now we will explore what does this filter method means. Let's just come here into iter, because what there is no difference between in iter and into iter, just the concept of the reference or the ownership. Now let me use the filter, and what I want it's saying that predicate. What does this mean? Let me get uh, closures, and filter means to filter out the values from the vector. So what I want, let me do one thing. Mm, Let's just get the what does this mean? This will module add the module or do the modulus. Let's say 1 modulus 0 is equals to 1. 2 modulus 0, oh sorry, 2, my bad. 1 modulus 2 will the remainder will be 1. 2 modulus 2, the remainder will be 0. So now let me use this iter tool, and there will be another. Let's save it really quick. Now let me just oh, I haven't added the. Now you can see it. There is nothing happened because of the collect, and then let's just quickly. I don't know why it's becoming too slow. I 32. Now you can see 2 and 4. What we had in the vector 1, 2, 3, 4, but what is printed in terminal, it's 2 and 4. So it has eliminated the odd numbers from the vector. So if I want to eliminate, let's say, the even numbers, so let's just do one thing. Oh my bad. The condition would be no. Let's just do one thing. It should be, we can do 3, or we can opt for 1 and then equals to 0, whatever. Now we did a modulo of 3 with and added the check that if the modulus or if the remainder is 0, then print it out. So we have 3 here and it's printed here. So what does this mean? This will repeat the multiplication of the 3. So let's say if I add 6, 9, so it will return it. So now let's move on to the next function, uh, filter. Now we have reduce. Reduce is kind of a thing. Let's say, what's the use case of reduce function? We can use reduce function to, let's say, accumulate the total of a vector. Let's say if I want to get the total of all these values, 1 added to 2, 3, 3 added to 3, 4, 6, 6 added to 4, it will become 10. So the total will be 10. So how to do this? There are multiple uh, ways to do it. So I can directly go here. I can, let's say, add the like mute value. Initially, the value will be 0, and then we can value plus equals to I. We can do this, and numbers. All right. Now, if I want to print the value, I can do this. Value, value, just two cargo run. Now we have the value 10, but there is another way to simplify these kind of things. Let's say total is equals to numbers dot iter, and let's just uh, reduce, and then reduce function will give you two arguments. The first argument would be accumulator, or you can call it ACC, whatever you want. And then the second argument would be the index or the previous values, the current value item. You can rename it with value or whatever you want. So now what I want to do, I want to uh, in add the item, the current value into the previous values or the total. Let's say AQ or AQ plus item dot. All right. Okay. Because we are not returning any iterations or the total, it's working fine. And then here, mismatch types, consider borrowing here because we are borrowing here. So what we can do, we can use the um consider borrowing here. Okay, so instead of iter, we can use into iter to get the ownership of both the values. So now we have the ownership of the values, and then let's print the total. Total. There is another thing. Yeah. Now what we have option right here. What does is option means? So who added this option right now? Now, what does this option I32 means? Whether there will be some value or there will be none or no value. So you can let's do one more thing right here. So let's just add a match statement here, and let's just instead of doing calculation here, just do sum. If there is some value, let's say let's say sum print println, and then some some, or if there is no value, so none, what should we do? Let's just println and then none. Let's just save it and add these. Oh, I have add. All right, let's just save it and add the control G cargo run. Now here you can see the sum is 10. We got the total of the uh, vectors. We got the total. So this is the way we can use the reduce function. There are multiple ways. If we don't want to use the match statement, we can uh, define it in the, let's just do this with another method. Let's copy this thing, assign it to a variable total is equals to, let's say, let's add match statement here. Match total. If there is some value, then print, let's say, some print ln and print the total value, or else just return the none. So this is the pretty much easiest way. All right, let's just save it. Is there any issues? Is there any issue? All right, perfect. Let's just do cargo run, and then we have the total 10. So this is pretty much it from the reduce function. I hope this is clear for you. And then the lines method. In our last video, we have used lines method to iterate over each of the line of a file, the txt file, or sorry, the string. So let me show you where we did use it. Yeah, right here, content dot lines. We we did uh, we have content as a string, and then dot lines function will break all these lines into, or iterate over all these lines, and we have the line as a string, each line. So this is the function that we have used or work. Yeah, this is perfect. Now sort versus sort by key. So let's just get into, yeah, here it is. Let's just comment all these stuff. Let's just comment this. Mhm. Let's just create a struct. Let's say city, and let's say name of the city will be string, and then let's say population or area, whatever. Population is perfect. Let's say U32. This 32 I'm just adding the random thing for now. I'm assigning, and let's just add the drive debug macro so that we can print the struct directly in terminal. So now what I want, let's just define, let's say city1 is equals to city name Karachi, Karachi dot to string, because we are passing the string type. And then let's say population is, we will take a smaller number so that we can uh, r- test this functionality out really quick, and then we can compare it with different cities. Population, let's say uh, 4 to 1, create 1 2. Okay, so city 2, city 3. Let's just New York, NYC, New York City, and then the third one. Okay, and then 1, and let's say a big number here. So now we have multiple functions to sort the values by key. So let's say if I want to sort the, let's just let cities is equals to vector of, the type will be vector of city, and then let's just get the city 1 really quick, city 2 really quick, and city 3 really quick. And then let's just iterate over cities dot sort, and then you can see where we have multiple functions. So what we are doing, we are using sort by key, and we have to define which key are we uh, planning to sort by. So let's say sort by, let's say x will be the struct, city struct, and then x dot by population. I want to sort by population. What happened? Um, cannot mutate the immutable variable, because the sort by key will mutate over the actual vector. So let's just make it mutable, and let's just add the print statement here. Cities, cities, and let's just save it. And okay. Now we have, okay, now we have New York City first, because it's the population of NYC is 1. Karachi on second number, 4 to 1, and then the third one is London. However, the actual vector was city 1, means Karachi was uh, in the first index or at the first place, New York was on second, and the London was on third. However, it has sorted this array or the vector. Now, one more thing. We have a function dot sort. It will sort out the vector. So let's say, mhm, let's just do one more comment all this stuff. Let new uh, nums is equals to 4, 3, 6, 1, 9, 10, and then let's just nums dot sort. We don't have to pass any closures or anything. We just have to numbers. Let's just run this code. Now we have the sorted vector 1, 3, 4, 6, 9, 10. That's perfect. Cool. So take this. Now we have enumerate and the next method, and then we will get back to the documentation again. As well as we have to review some of the performance related documentation or the stuff from book. So let me just get here. Okay, let's just understand what the enumerate function is. So let's say we have, uh, let's think about an example. So to enumerate, what does this mean? Let's just uh, loop over this, the vector city. For city in cities, let's say, let's just iterate over all the cities, print ln, and then let's just print city. What I want to get the index of the city. What does this mean? In which place the city or the this value is in the vector. So let's say I want to get the index number with the value. So how to get this? So we have a function. Let me just do one thing. Now let me add dot, and add the let's just review the intelligence. What are the functions that we can use? We have fill, first and get. Into boxed is iter and iter mute. So what I am doing right now, I'm just using iter, and then let's just use the enumerate. Now you can see here we have the type usize and the reference of the city. If I remove the iter, what we have, I have the ownership of the city, the ownership, because I have already told you the if I use if I try to use the vector in with for loop, it will take the ownership of the vector. If I use the iter function, let me just if I just use the iter function, it will take the reference of the vector. So let's just get the index and then city. Let's just city number, let's say, and then the city dot name. We will print the city dot name, then first index, and then city dot name. Let's just print it, save it, and then run the cargo run command. Everything is perfect. Yeah, right here, city 0, Karachi 1 and 2. So this is the enumerate function, and now next method. What this next method means, with by name you can easily understand this next function. What it will do, it will go next to the next index. So let's explore this really quick. Okay, now let's say Let's just copy this. Where is this thing? Yeah, let's just copy this. Oh yeah, let's just copy this. Let's just get it. Implemented. And then what I have to do, I have to test the next function. Let's say nums dot iter dot, or just do one thing. Let nums iter is equals to nums iter. We have the nums iteration of the numbers. So let's say if I want to nums iter dot, if I press dot, I have, there are multiple functions that can be supported. So what I want to do, I want to use the next function. What does this? Now you can see an error, cannot mutate immutable variable. So add the mute to this nums iter. All right, this is perfectly fine. Let's just println nums iter num iter. We have nums iters 3, 6, 1, 9, 10. Where is 4? What does this mean? Where is 4? If I, let me comment this line and let's just run the cargo run command. Now here you can see 4 is here, but when I have used the next method or next function, what does this mean? This will skip the current index where it is iterating over, and then it's going to the later, or it's printing after this the current index. So let's say, let me reduce all these. What if I have two values, and if I'm if I do the next if I'm using the next function for the 3 times, let's just run the cargo run command. We have an empty array, but why it hasn't thrown any error, let's say, or it hasn't been panicked index out of bound. I don't see any error. So why? Because the next function is, the type of the next function is option type. So option type contains the sum or none. So this is pretty much it. So you can see that it will not panic. You will see program will run perfectly fine. So now let's just take this next method. Why are iterators lazy? Because I have already told you iterators are lazy because until we are using that specific that specific variable where we have assigned, where we have used the iter function, until we are not using the that specific variable wherever we want, it will not be included in the program, kind of a thing. Let's say अगर मैंने अपने प्रोग्राम में आइटर फंक्शन यूज किया है और असाइन किया है किसी वेरिएबल को, और जब तक मैं उस वेरिएबल को यूज नहीं कर रहा, वो हमारे प्रोग्राम और हीप एलोकेशन का पार्ट नहीं बन रहा. सो इट विल नॉट टेक द रेफरेंस, वो कोई पॉइंट नहीं करेगा उस मेमोरी एलोकेशन को. सो इट विल नॉट बी pointing to that specific memory block until we are consuming the variable where we have assigned, to whom we have assigned the uh, iter function. So that's pretty much it from all these topic. Let's just quickly review what they have in the documentation. Where it is. Improving our IO project. They are improving the IO project by by using the unwrap or else method, because we have already used unwrap or else method in our last video. So we have already covered the advanced topics in our last video. So there is no need to review. So now they are implementing the iterator type or the iterator trait. So now they are using args next. So we have already learned about all these stuff. Comparing performance loops versus iterators. What is the difference or performance difference between loops versus iterators? So to determine whether to use loops or iterators, you need to know which implementation is faster. The version of the search function with an explicit for loop or the version with iterators. We ran a benchmark by loading the entire contents of the Adventures of Sherlock Holmes by Sir Arthur, and the benchmark is mostly similar. There is a minor difference. So you can use whether if you want to use iter function, you can use it or directly use the uh, loop. So before moving to the summary, let's just quickly open the book. Let me let's just quickly and let me show you what I want to how what let's just quickly. Okay, so here we are. So let me just quickly switch to the we have the rest book, and here I have marked some of the stuff right here. So here we have, yeah, it's perfect. Rust closures are designed to be faster than function pointers, fast enough to you can use them even in red hot performance sensitive code. If you are familiar with C++ lambdas, you will find that Rust closures are just as fast and compact but safe. And then after that, you can see they are not garbage collected because Rust is not works on the principle of garbage collection. We have to allocate memory by ourselves. So like everything else in Rust, they aren't allocated on the heap unless you put them in a box, vector, or other container. So if we try to allocate any of the specific closure. So closure will not by itself be allocated to heap until we by ourselves allocate it to the heap or in the memory. So now there are a lot of stuff. Let me switch back to the and let me get some other functions and let me show you what are the functions that are supported. Let me show you some of the functions. So I'll set up proper cameras and for to display the book and the functions from that, or I'll take the screenshots in later upcoming videos. So let me show you what are iterator adapters and from book. Let me switch back to the okay now here. Iterator adapters. Once you have an iterator in hand, the iterator trait provides a broad selection of adapter methods or simply adapters that consume one iterator and build a new one with useful behaviors. What I have told you previously that iterator by itself is a trait, and then the function like map, filter, reduce, they are kind of using the iterator trait and implementing the functionality uh, over it. This is kind of a wrapper thing. So let's say map function is wrapping its functionality over the iterator trait. So this is the simplest way to understand the iterator adapters. And then let's move on to the further. So map and filter, there are a lot of examples if you want to test these examples. Let's say there are multiple functions. Let's say filter map, flat map. There are flatten, skip while, mm, take and while. So how we can use the take while by implementing the iterator. They are creating some custom functions by wrapping or by implementing the iterator trait. Here you can see implement iterator item self item where self sized. What is this? We have already learned that we how we can assign types to the generics, and if let's say right here, so here we can assign types to generic directly. Let me show you on the screen. Control 1, and let's get into the code. So here we have already covered these examples. So let's just go back to the main function. Let's say we have a generic here. So we have an option, or we have a choice that whether we can declare the type here. Let's say it is option type 32, or whether I can declare the type here where the where the and the type of I can declare. So we can do that as well. So let's just get back to the book again. Let me show you how we are, what we have in the book. Okay, now we have e-cable. They are implementing different functionalities and spec and so on and so forth. So these are the enumerate function. I have already told you that we have two things. The first one will be index, second one will be the item, the current. And then there are counts, sum, product. We have already reviewed max by min, max min, max by min by, max by key, min by key, fold, r fold, position, r position, any and all. And there are a lot of functions. You don't have to uh, remember all these functions, or uh, might be you never use it, or you will never use it in your programming. So don't worry about that. The major functionalities or major functions are map, filter, reduce. They are some of the functions that can be used in your daily programming journey. So let's say find will be used, collect, and from iteration, and these are the pretty much it. So let's just let me show you one more thing before ending, where it is now. Yeah, here, implementing our own trait. How iterators? How we can implement our own iterators here by using impl iterator, and then we can declare for, and the I32 range is a struct. So they can, let me switch back to the, let's get back to the, let's close everything here, get back to the code again. So we have already discussed about the generics, how we can define the type I32, and then we have another choice whether we can declare this same type right here. This is perfect. Now what I want to explain you, let's say I want to build my own custom iterator. So how can I build it? We have a struct city. So impl iterator for city. Now you can see what this iterator is. I have to import that specific trait, or I have to create the iterator trait. Not all trait items implemented. Item next. So both of these, because we have already covered in our previous videos that the trait must. So wherever we will declare trait, we must have to define all the functionalities or the types. Let's say we have a function next, we have to implement that. Right now, let's just do unimplemented function. And then we have another thing. item. What item is? Type item. Let's just save it and then see what we are missing. Option cell function next is implemented, which will return. Okay. So we so this is kind of a thing that we can how we can implement our own custom iterator. So this is the syntax how we can define our own iterator. So this is pretty much it. So just read out the summary and just conclude everything. So we are around at 1 hour and 5 minutes mark. So let's just close it out. Closures and iterators are Rust features inspired by functional programming language ideas. They contribute to Rust's capability to clearly express high-level ideas at low-level performance. The implementations of closures and iterators are such that runtime performance is not affected. This is part of Rust's goal to strive to provide zero-cost abstractions. Now that we have improved the expressiveness of our IO project, let's look at some more features of Cargo that will help us with share the project with the world. So before ending, I have forgotten to discuss how we can implement closures in JavaScript. So let me just show you the example from book really quick because we have already explored the simplest example from the code, but let me show you what the book has. Let me show you really quick. Where it is. Let's go back to users and right here. So we have it here, and then just really quick. Okay, right here you can see. Okay, perfect. So here we have function start sorting animation. This is a function, and inside that function we have key function. So here you can see key function, and then inside that key function we have if pending sort dot cancel. And now you can see the comments now kick off an animation passing key function to it. The sorting algorithm will call key function later. So we are creating an object, new sorting animation, and then we are passing cities and key function. So we are passing a function to to an object. So it's kind of a nesting. It's becoming a nested tree, but this is how the closure, this is another example of closures in JavaScript. So this is pretty much it from my end. I hope you have learned a lot of stuff from this video. So we will cover we will review about we will this is the easiest topic, cargo and crates. We have already installed the crate in our last video, the clap crate. So it's we will move on to the much more advanced topics from the next videos like smart pointers. We have box, dynamic arrays, we have RC, ref cells, references. Then we will move on to the threads, how we can manage threads, then mutex, logs, how we can. So there are a lot of advanced topics coming in. So let's be connected. Subscribe to my channel, and if you have any queries, just let me know in the comments or just reach out to me on my socials. I'll try to be more responsive and answer your query or address your queries. So this is pretty much it. See you in our next video. Bye.